Okay, well, I suppose we're ready to start. And look at all of you that are listening to Andy right now. Yeah, yeah, it's a shame that he's going on at the same time as me. Anyway, hi, my name's Ray. Hey. And my talk is on digital puppetry. Um, and I don't know. I'm from America. I came a long way. This is really exciting. It's my first time in Europe, first time to Amsterdam, first time to the Blender Conference, first time unemployed. Woo! Yay! All at once, right? Okay, this is very good. And gosh, my computer's acting really bizarre today, so I'll be really surprised if we get all the way through without any problems. Okay, so the first question you're probably asking is, what in the world is a digital puppet, and why is it a big deal? This is the question we're going to answer right now. The what is this. So you have human motion that's being converted into computer animation. And there's a squiggly arrow here in the center because there's something special that happens in between that makes digital puppetry puppetry and its abstraction. There's not necessarily a one-to-one. Now, I'm going to get more into this as the talk goes, but abstraction is important. Just kind of remember that. There's also a live element that comes into play. I mean, all motion capture is natively sort of just a more messy form of motion compared to doing keyframe animation. And in some cases, that's desirable. Like if that's something that you're looking for, then yeah, motion capture is kind of a way to go. But, all right, so here's the big deal. I'm sort of going like from beginning to end right here at the beginning. The big deal is this. A graphical user interface element has the capabilities of fiddling with one thing at a time. Now that thing, you don't really have to think too hard about what that thing is, but can do one of those. And your brain, every single one of you, is perfectly capable of doing about 12 of those simultaneously. And each thing that you're dealing with might have multiple degrees of freedom. The 3D connection, I forget what it was called. I bought one too. Yeah, the Space Navigator. Yeah, that's like a has 6 degrees of freedom, which is location in X, Y, and Z, and rotation in X, Y, and Z. So let's look at some of the pieces of hardware that you're usually interfacing with. But we'll start with your hand, which has about 21, and this is like that's just the number that I added up. If you look at all of your fingers as having 3 XYZ location, and then your palm having a grouping of all of those and a rotation element. That's a lot of, information. Whereas your keyboard button can do like one thing, and it doesn't have a very good resolution, and at least it's absolute, at least it knows what it's doing. And the mouse is actually a device that I can't stand. Because it's relative. It only cares about where it just went from where it just was, and I don't know. There's not much to say about the mouse. Now, there are plenty of devices out there that utilize potentiometers. Now, if you're not into electrical engineering, it's simply something that can read analog, like a 0 to 1, like a low voltage to a high voltage. Joystick, a slider. Plenty of devices out there have these, and the Waldo is a name that came up from Jim Henson just before he died in the early 90s. And it's, well, no, I take that back. Sorry, I learned this the other day. A Waldo was originally for people dealing with volatile chemicals, actually. You need to like have the robot move your glass from here to here. You move your arms, it moves its arms, so if you spill the acid, it doesn't, burn your hands off. But it was really Jim Henson that came up with the idea of using this for animation purposes. And I've taken a clip from the Jim Henson Hour show that I'm going to play here. And hopefully the sound will work right.
But now normally Steve Whitmire, one of our chief puppeteers, is operating this guy, but I'll just do it to demonstrate it. And over here we have Rex Grignon, who is our computer animator. Okay, and what Rex is doing is he's taking these moves that I'm doing with my hand and converting it into Waldo on the screen there, see?
Neat!
And the really great thing is that the computer does it all in real time. As Jim moves his hand around in the puppet, the image of Waldo flies around on the screen, too.
So it's like Mr. Henson is working a puppet, but what you get is a moving television picture.
Say, listen, Jojo. Have you ever seen a computer graphic sneeze?
No, sir.
Oh, it's one of the wonderful sights of the world. Let me tell you. Watch this.
Right.
Here we go.
Oh, my goodness, you seem to have sneezed your skin off.
Yes, well, I'm sort of a wireframe now. Isn't that wonderful?
Yeah.
Yeah.
Very impressive. But I do feel compelled, with all due respect, to point out that the picture of you still looks pretty terrible.
The image you see on the screen is called a low-resolution picture. It's not really that good, but it's about the best the computer can do in real time.
But you see, what we can do is we can take this crummy-looking low-resolution picture and we can run it through yet another computer into high resolution, and it comes out stunningly beautiful like this. Come on, Jojo.
I hate that clip. So, I mean, years passed, and the Henson Company kind of had to drop the digital puppetry thing for a while because they had to wait for technology to kind of catch up with such a big idea. There's a new show called Sid the Science Kid. It's currently running on like PBS Kids or something. It's actually not a very good show. But the technology behind it is fantastic. They're using full body motion capture, and these like, and a modified version of what Henson was doing in like 1992. And here's a guy talking about what it's like to use one.
I do a vocal performance and a puppeteered performance, or real-time animation, at the same time. And this performance is welded onto the body of the person in the motion capture suit on set. So I stick my hand in a mechanical glove and have a joystick over here, so it's like playing a video game sort of deal while I'm doing the voice.
Oh, Grandma, it's not a dog, it's just Dad.
It has the looseness and the funness of a performed medium rather than an animated medium. It has that looseness of the Muppets. And that's very, very cool for us. So we call it digital puppetry because that's really what it is.
Okay. Well, wasn't that exciting? Movie time's over. What is Blender's current relationship with all of this, possibility? Well, solution one, and I'm certainly not the first one to take this route, is to use the Blender game engine and simply use sort of a live puppet scenario. My character is called Raul. I'll show you in a second. And my controller of choice, my Waldo of choice, is a PlayStation 3 controller. Ooh. I picked this particular controller over every other one because it happens to be pressure sensitive on every single button, which is really, really nice. Glove Pie, which unfortunately only runs in Windows. And this is feeding all of the controller information into OSC, which is a really nice open source standard that was brought out to sort of replace MIDI. It works on a network protocol. If you really want to know, just ask me after the talk or during the question session. It's actually kind of boring. And that's, of course, feeding into Python, which is running in the game engine. So let's do a demonstration. So here's all the files you need, which is kind of a mess. I have here the file that runs in GlovePie, and oh, look at all that code. But here, we'll just look at one line, because this is really all you need to understand what's going on. I'm making a variable called like gx. That's just the g forces, is the tilt of this thing. And mapping, you know, the variable that comes from the controller itself from its native values into a number that goes from 0 to 1,000, and then rounding it off so that it's an integer. This actually makes OSC a lot faster. Other people have been doing OSC experiments. And part of what makes it faster is not using floating point. As soon as you use decimals, it really slows down. So this is just a trick I learned while working on this stuff. And then every single value is just spit out to this network address, port, blah, blah, blah. Whatever. We're just going to run it. And there you can see it's working. This is just, you know, a readout. Yes. Yes, because OSC converts every number into a Unicode character. And if it's a whole integer somewhere in between those boundaries of Unicode, then it only needs to send one character, and da-da-da-da, it goes faster. I'm having a heck of a time working with this second monitor. Oh boy. Okay. Well, this is code that I stole from the person who did the Wii remote connected to the game engine. It was an awful long time ago. But I sort of restructured it and, you know, wrote it myself. This is actually pretty easy to read. I won't go into too much detail. But, you know, there's OSC. And this function right here just like sets a bunch of variables to all the data that comes from OSC when you run that function. And then I'm just sending each object. There's one bone, and then there's his actual head, those variables. And in the game engine, this is going to be really small. Well, tell you what, we'll just run it. Hello, Blender. How's the audience feeling? I don't know, Raul. I haven't really asked them yet. How are you all feeling? Good? Yeah? Are you all like, who in here is a Jim Henson fan anyway? Can I get a show of hands? Yay! I like Jim Henson. I never saw him much, you know. Well, you know, he was only, hey? Hey? Oh, well, here. This joystick here controls the turning of his head. I have some of the accelerometer data controlling sort of the bounce, so that you get a sort of a more toony feel when he nods and turns and things. Yeah, it really does. And over here, the D-pad, depending on pressure, is using shape keys. So he can be happy or sad, excited or confused. And if you really get your hand all wrapped around it, you can press down on pretty much everything at once. Yes, that's... And the real magic that allows this to happen is... let me quit it real quick. Sorry, you were trying to take a picture at the same time. The shape action, which is bound to a property. And then, whoop. This is not going to look very nice, but each one of these things, is mapped from frame 0 to 1,000. And this is a lot like Python drivers. So, some of these are modified like the Oh well, I won't bother. But because I don't have a home key on this, and I can't get the. Well, you get the idea. And we'll come back to Raul later. So. There's also like a second solution where I tried to use script links to do the same thing, just like in the timeline without running the game engine at all. But this slide isn't supposed to be here anymore. It really doesn't work. I thought it worked. It really doesn't. So we'll just skip that. But here we'll just look at the entire process that the Henson Company sort of set out. And the beginning is this process of at least seeing what you're doing while you're moving the controller. And that seems to be, doable. And then rendering in Blender is fantastic. We don't really have to worry about it. So the only thing that's really missing is the ability to record. If we could do that, then we could start using a workflow similar to what they're doing on Sid the Science Kid. And from my understanding, a regular TV program that's 3D animated takes about 1 month per episode. And on Sid the Science Kid, they're spending about as much time on each episode as shooting a regular sitcom. So like less than a week's time, because they can just act it out and do all the lip syncing gets done at the same time as you doing the voice acting. You pick the best cuts you like, you edit, you're done. And they did like 40 episodes in a year's time, which is incredible. I certainly think that there's a full potential that's not here yet. It's either 2.5 or it's 2.6. I'm not really sure. And just as a review, we all know that every action is going to have this operator and context and such, which the GUI or the keyboard can feed into. So it's really just a matter of, well, I'm not a coder by any means. I'm more of an artist. But getting MIDI to talk to the operator. That's it. And in some cases, making it context independent, because there's certainly an issue that comes to mind for me that, if you have like 30 inputs all coming into the same software, they'll necessarily need to be bound to one specific action. So I thought a good way of looking at how it should look is to look at some other software. This is Ableton Live, and music software has been dealing with like external hardware devices for a really long time. Does anybody else do music in here? Just a few of you, but you know what I'm talking about. Like MIDI binding is something that's really easy and like solid in every other software. Ableton's nice enough that it does OSC too. But here, look at this. This is sort of a non-blocking interface as well. We have dials and sliders and things that are part of the interface. And then you hit this button up here, and some of the interface elements turn blue temporarily. While you click on them, twist some knob, push some buttons, slide some slider, do anything, and now those two things are connected. You switch back, and then as you turn your physical knob, you turn your software knob. And context doesn't mean anything anymore. The GUI, doesn't really care. And then when you record, everything that happened, gets recorded. And, the IPO could be used the same way that they were doing for Python drivers, like I said. Like, the input doesn't necessarily have to be one-to-one, but it does need to get turned into a normalized number. Like joysticks usually are like a negative 1-to-1. Sometimes you have to deal with like, is it going to be 0-to-1 or is it going to be negative 1-to-1? Or how am I going to deal with this? And then how big is it going to get once it gets in there? So mapping things like that, I think the IPO does a good job of. It did for Python drivers anyway. And just a brief look at some of the software that's out there right now. There's tons. I can't even count how many really fantastic MIDI controllers are out there right now. I seem to remember a ton. You did a video and you were talking about you would have liked, multi-touch to eventually come into play. And when I started thinking about that, the Jazz Mutant Lemur is probably the most impressive multi-touch piece of hardware that's out there right now. You can set up as many multi-touch buttons and dials and all sorts of weird controllers on the surface. It's good for up to 20 multi-touch inputs. That's you and a friend with all your fingers on it. And then there's also lots of small MIDI controllers that fit on your laptop these days. And software solutions like T-Beta that do similar to what the Lemur does, except with more software. And to look at how much you might be spending, the Lemur is very expensive. Some of these newer MIDI controllers are very affordable, and T-Beta is free. So what this all gets to, for me, is what I call the zenith of multimedia. There's a lot of software out there, namely processing, VVVV, Max MSP, Pure Data, and these softwares are doing a really good job of taking tons of different inputs and offering tons of different outputs. And I think Blender 2.5 is going towards that, tool for making tools, and if it can accept a lot more hardware, things like digital puppetry and motion capture and abstraction of human motion, like live performance, is going to be easier to integrate into your animation projects. And it certainly works well for audio. So I know for a fact it's going to work great for motion, visual motion as well. And that's really the climax of the talk. So thanks. So at the end here, I would love to take your questions, and if you'd like, come up and play with Raul, ask the question with him if you want. This is just the way I decided to do it. So I'll just switch back and put him on full screen, and you can just come up here and mess with it, or ask me a question, I'll relay it. Whatever you'd like to do.
I want to try it.
Get on. Yeah, mainly the joystick.
That's really fun.
Yeah.
You have to practice.
Yes, practice is certainly an element that comes into play. As you get used to it, you start thinking a whole lot less about the fact that there's a controller in your hand and a lot more about the facial expressions of the character. And I could see it, if this is something that you were doing regularly, you could say, oh, I'm going to do, a character's dialogue today, and just whip it out in an afternoon. just like that.
Very difficult to do that.
Very, yes.
Be a puppet. What is the trick for puppet players? Hello. How are you today?
You really just don't worry about it too much, honestly. You just let it go. He was. He was very good. Anybody else? It's really, if I encourage you to, I majored in interactive multimedia. I want it to be interactive, so come up here or, go socialize, really. I can't believe I'm at Blender Conference. I want to get out there and talk to people. So come up, talk to me. The talk's pretty much over.
So, Ray, it would be pretty possible to, save motion capture. It would be pretty possible to save the signals that you're generating from your device over there in PD, in pure data. So you could basically just have an object that just sort of has a timestamp and then what event you had in it, and then we could basically send that to Blender, and you could replay a sequence.
That's almost interesting, except for the fact that when you play back in PD, you're still only getting a live output. Like the best I could think up, if I wanted to edit this or do anything with it afterwards, is if I gave him a blue background and then did a blue screen, like recorded it to tape or something really retro. But no, the purpose for having a head here is really just to get facial movements. Right. And then later, this is going to get, stuck onto the head of the character. You could do the rest of the character in another way and then do it in high resolution and actually render it out.
So you want to basically just save the IPOs
right.
from your live performance, right?
I've tried doing that in Python, but as soon as you start trying to make an IPO, it doesn't take variables anymore.
No, what you have to do is you have to generate the curve, regenerate the curve. Basically, you just delete the one that's there and regenerate the points, and it's a pain in the neck. And the guy, who's the expert on that part of the code, where the IPOs are being evaluated? Who? Yeah, is he here? Oh, okay. Yeah, it would just be cool to get just one hook in there to do something like this a little bit easier. So I'll talk to him.
At SIGGRAPH, I had a great demo from people in New York who are developing a multi-touch pad, and it delivers you a complete grid, and it had a resolution of thousands of sensors on a touchpad, so you could really not only play with 20 fingers, but with everything. And they also had a piano demo on it, and several other ones, and they would love to work with Blender on it too. And I really feel it. The touchpad was big, and it was really nice to have that kind of space to play with. And probably for puppeteers, it would make a great interface.
Yes, and that's why I like the idea of the lemur so much. It's like a weird interface. Like it would be too weird to try to touch Blender itself. Maybe. Yeah. You could, if you wanted to, like lay out your own little buttons and things. But there's definitely a lure because, like, the guy who did the iPhone talk just said, like, your fingers are very blunt, and it's hard to get into, like, really tiny sliders that get too close to each other. So it's nice to be able to abstract something that's big and easy to touch and then just have it feed into something. That's why most MIDI controllers are so mammoth. So you can just really spread out.
In terms of interface, there are some really nice experiments with the Flar toolkit with these markers. So if you put these markers in front of on your body and you dance around the camera, Flar toolkit gets this information of the different markers, and you could actually use your body as an input device for this kind of digital puppet without having anything, without wearing anything. That could be there are some nice videos on Vimeo on YouTube.
Yes.
That's fun.
I could see really almost any device making your imagination run wild. The lemur did it for me. Anything could do it for you.
I was going to say there was actually a guy who talked at the Seattle Blender user group. He showed off a project he was doing where they just essentially did a green screen of him like moving his arms, and then that would map to a rig as a puppet to like a dragon head and stuff.
And that's nice. Yeah, I did all right with the man candy thing, like back home. I just couldn't get it running here. I had his arms moving around and things. Meh. Too bad. So sad. Didn't work. Anybody else want to try it out? Or? It helps too if you get your index finger sort of curled around so you can touch all the D-pad buttons at the same time as your... It's hard to do. Go ahead.
What about voice or vowel recognition to do automatic lip syncing?
That is entirely possible, but what you will find is that your brain is a much better tool of analyzing facial movements to audio than a computer. I will leave it at that.
I've actually recently been looking at the research for that. It has come quite a ways in the past 2-3 years, but yeah, it's still not all that great. I don't think any of the researchers are really taking into consideration the facial animation work that's been done by that was done in Stop Staring. I mean, I've been reading through all the papers, and nobody's really taking the ideas that he's put into that really into account for when they're doing their algorithms.
Well, the Henson Company has a much more sophisticated controller. On Sid the Science Kid, you could see, you know, they got the O. Anytime he made an O sound, like O, and he could make his mouth get wider, and he had control over eyelids and I think maybe both sides. But he had like his whole arm in the thing, and you know, I guess if you wanted to go through the effort of building something to get a lot. Go ahead.
I realized that your main concern while you're using the game engine is to record the movements we are doing right now, so we can reuse it to render.
Yeah, if movement could be recorded to an IPO.
Because you actually, I mean, right now at least in the Blender 4.9, you can even access the Blender models inside the game engine. So actually, you can even. I would suggest the more safe approach would be to like store all the movements in as a text or something like this, and then in Blender you can reconvert it to IPO.
I could definitely see that. At the moment, the process is already so complex that I see it as sort of a hack. And really, it was just sort of a test. And what I would really like to see is just, something for 2.5 that could read hardware. I don't know that Raul is ever going to get any further than he already is.
What is the problem?
The problem?
What do you think 2.5 will solve?
I would hope that that it would be able to interpret an OSC signal. That's it. And that you could bind...
But what is the problem with that signal? I have no idea what it is, but why can't you do that in 2.4? Because it's not part of the event system. You have to make your own driver or that kind of thing.
Because it directly accesses, like, some GUI element. In other software, I think it's hard to explain. Oh.
Blender keeps working.
It's I don't know why it's hard to explain.
I know how Blender 2.5 works. I've been designing it, but I know we wanted to make it ready to support other input devices.
Yes.
Not only mouse, keyboard, but also multi-touch or whatever. But this is, of course, a very special case. But this is a multi-channel input device, which is actually not meant as a pointing device, but as a stream of data, as a kind of data stream. This is not an event. This is more like a input stream, which is supposed to work continuously, right? Like any mocap system.
Yes.
You're not going to use Blender with this system.
I would hope that someone would be able to. That's the point I think I'm getting at, is that you should be able to press play and have, the motions being happening with the timeline, and when you press record, have it get baked to IPO. Okay. And then stop recording and then just decide, do I want to keep it or not? And you could just throw it out or do another take or whatever.
But you know how this is a standard MIDI interface, right? The OSC or whatever.
OSC is very standard, yeah.
So are people here familiar with OSC coding? Yeah. But that's kind of things we need as expertise in our team. I know how the event system in Blender works, but I have no idea how to efficiently hook it up in a way that you can have both stream, but also OSC to control Blender. That you can say, well, I want to have on my piano when I play A, I want to have Blender play the game, right? Yeah. That kind of things.
It's pretty. What you would do is you would take. Let me explain how you would do this. You would take something like your pure data to, to sort of be a fronting
that device he's got in his hand over there, all right?
Sure.
So he's basically generating a signal on the fly, all right? I could save that as an IPO, all right? And then I could just basically send an OSC message to Blender with the new IPO. Here's a string of numbers. Like what I could generate the tuples for the IPO like that, and then we could just sort of associate them with whatever object you want in Blender, and then you'd be okay. You could do it right now in Python in 2.49. It's difficult code to write, but I could do it.
I mean, I would appreciate to have high-level design feedback, like how would you ideally have in Blender 2.5 access to this? How would it work? Do you need a visual interface?
Yes.
Is it all Python? Or
either similar
how do you define
to
focus or mouse pointers?
Yeah, either similar to Ableton, where you can switch it into a mode and all the GUI elements give you the ability to like click on it and then hit some piece of hardware, and now they are one and the same. Or some other software, you right-click on anything and you say link to a controller, and then you just move something, and it reads in like whatever MIDI signal just got sent in, and then it says, all right, now this controller, which has some identity, like controller CC15, and then it binds it to whatever action that button or slider usually has access to, and then every single time you move that hardware, it always only modifies that action, no matter what's selected. So.
Basically the same, our Wacom input, the pressure sensitivity, and the angle sensitivity for Wacom, so we have it hooked up to our sculpt. It's the exact same thing, except so that's where we hook up. It's the same way that we hook up our Wacom pressure to our downloads.
I got an idea. Let me run this by. What if we had a little sort of another panel for starting the game engine? Instead of just hitting P, you hit a button start. Then you could have like sort of an area for saving presets to save these baked animations, something like that you could keep within the Blender interface. Then you wouldn't even necessarily need like an external program. You could just build OSC straight into Blender, and then you could have another panel that just manages your different.
Yeah. Well. Can you put the controller down for a second? Let me go to the slides. Now, it's going to be hard to see here because the resolution on the projector's not, well, sorry, it's my computer's fault. But in normal mode in this program, like, sure, there's like a menu of things here, but when you get into the MIDI map mode, what you have here is a list of controllers, like this is controller 2, 4, 12, etc., and they're being mapped to some element on the GUI. So it would be it could be something that looks a lot like the outliner, but it would really just be nothing more than a way to connect some thing on the hardware device to a widget on the GUI. Yes, to the RNA. So hardware to RNA, and then something so that when you press record, you could just everything that's moving on the hardware gets recorded.
We should have Brecht here. He will tell you immediately and start coding, and tomorrow you have.
Yeah.
We go with the coding upstairs.
Well, I don't know. I think that's probably about enough. If nobody else wanted to try. Oh, yeah?
No, it's not a question. It's just to say that having a MIDI opportunity to connect, that there's a lot of hardware that use MIDI to connect to computers. So other than instruments that are musical instrument that is a standard, also scientific tools, technology tools
I agree.
use MIDI. So when you have MIDI available as input, a huge amount of stuff you can insert may result in some Blender action and stuff.
I agree.
So any developer who knows this media stuff really well, I mean, contact me, ton@blender.org, or go to the Blender Developer IRC channel, and we set up some little project, and I will explain to you how it can work or how to get it to work. It should be not too complicated.
Cool.
Okay, thank you.
Thank you. Yeah.
Awesome. I really like it.
Oh.
Great work. What's the problem with